All right, the interior of a circle, inside the circle. The exterior of a circle is the set of the points outside the circle. So we've got some lines and segments that we're going to talk about here that deal with circles. A chord is a segment whose endpoints lie on the circle. A secant is a line that intersects a circle at 2 points. And a tangent is a line that hits it in one spot called the point of tangency, which would be C here. Remember, when we write our lines, either we use one cursive letter or 2 uppercase letters. So let me show you how we could go through that in locating these things. So identify each line or segment that intersects circle L. Okay, chords. Well, I can see that KM is a chord. So a chord would be a line segment. You could also say JM, the segment part of it, is also a chord. Secant, that's a line that hits 2 spots. So JM would be a secant, but you'd want to make sure you put a line above that. Okay, I don't see any other secant lines in that circle. Tangent. All right, this is our only tangent line. But there's only one capital and one lowercase. This capital is indicating the point of tangency. This M is what is, so line M is what is showing you the tangent. Okay, diameter then, KM would be a diameter because it goes through the center. And then you got a whole bunch of different radii there, LM, LK, so on and so forth. So does it make sense, the difference between a line and a segment on those different things that deal with circles? All right, let's try that again. Chord, secant, tangent, diameter, radius. All right, a chord. RQ would be a chord, the segment. Okay, so with the segment ST. ST would also be the segment part, would be a diameter. The line part would be a secant. Okay, tangent, where it hits at one spot, that would be over there at UV. Those are both capitalized. Tangents are lines. And then radius, you know, you've got PS, PT, and the order you put those letters does not matter. So those are the types of line segments that you need to be familiar with in this circle unit. Okay. All right, so 2 circles are congruent if they have the same exact everything, same radius. Concentric circles are inside each other, they have the same center. And then tangent circles mean they touch in one spot. You can be internally tangent or externally tangent. Okay? Find the length of each radius, identify the point of tangency, and write an equation of the tangent line. Well, we've got 2 circles here. We've got D. The radius of D is, what is that, 3. The radius of C is 1. Okay? The point of tangency is right here. It's where they touch. That would be at 2, -1. The line of tangency, they're always only going to be either horizontal or vertical. Well, this is a horizontal line, so the line of tangency is y equals -1. Okay? Let's try that. No, that's it for that one. Okay, a common tangent means that it's tangent to 2 circles. Also, this whole chapter, as I'm going through this, make sure you're looking, all of this stuff is in 11.1 on the online book, all the formulas, that's where you're going to have to go to get all that stuff for this chapter for the rest of the year, basically. Okay? So common tangents can cross, they both hit in the same spot there. Okay, first big formula today. If a line is tangent to a circle, then it's perpendicular to the radius at the point of tangency. That means those 2 are perpendicular. Okay? And if it's perpendicular, then it has to be a tangent line. So let me show you how some of these problems work. So remember, a tangent and a radius are perpendicular. If 2 segments come from the same point and are tangent to the circle, then those 2 are going to be congruent. Once again, these are all located in section 11.1 of your online textbook. HK and HG are tangent to F. Find HG. Well, if these are both tangent, then they're equal. So 4 plus 2a equals 5a minus 32. 3a equals, what would that be, 36, so a equals 12. Plug it back in, 12 times 2, 24, plus 4, both would have to be 28. So you would set them equal and solve. Okay? Same thing here, you could set those equal, they're a tangent. I'm not going to go through another one. But you'd set them equal, solve for x, and then plug it back in, because they both come from the same tangent. All right? All right, that is it for 11.1. Any assignments that come out of the book for you guys for geometry, I will always give you odd problems. There isn't a whole lot out of this section. I do want to go through 15 because it is going to be on your quiz, I believe, coming up here. Let's do it. Oh, back to what I was saying before. I give you all odd problems because you can look them up in the back of the book. And make sure you have that resource sheet open that I sent to you. It's got all access to the online book, online calculators, all that stuff. Olympic Mons Peak rises 25 kilometers above the surface of planet Mars. All right, there's Mars. There's Olympic Mons at 25. The diameter of Mars is approximately 6794. So we need to find the radius of Mars. That's going to help us out here. So I'm going to take 6794 divided by 2, which is 3397. Okay? What is the distance from Mons' peak to the skyline, or to the horizon, excuse me? Well, that's right there. That's a tangent line. Hey, if I draw this, that's the radius. That's 3397. What do we know about a tangent and a radius? They are perpendicular. Well, hey, I also know that from here to here would be the radius of Mars, so that's also 3397. And from there to there would be 3397 plus 25, which is 3422. So we're trying to find x there. We can do Pythagorean theorem. People mess this up. They put the right angle over here and they get all messed up. Remember, the tangent and the radius are perpendicular. So we can go 3422 squared, since that's the hypotenuse, minus 3397 squared. So let me do that really quick. Take the square root. 412.88 kilometers. There is one like that on your quiz.